We are going to continue on in Unit 3 and discuss the law of conservation of mass. In Antoine Lavoisier, is considered to be the father of chemistry, modern chemistry, because he relied very heavily on quantitative measurements and careful experiments. And so through these experiments and careful measurements, he found that matter is neither created nor destroyed in a chemical reaction. So let's look at a reaction. This is a reaction that goes on in a lighter, like to light a candle with, to light a cigarette with. This is a butane lighter. So the fuel in the lighter is butane. The reaction is a combustion reaction, which requires the presence of oxygen. Now, in reactions, what you have is reactants being converted to products. And you can think of this arrow, this reaction arrow, as kind of an equal sign. And you can consider that especially when thinking about the law of conservation of mass. So matter is neither created nor destroyed in a chemical reaction. So the mass of your reactants should equal the mass of your products. So let's see if this is true in this butane lighter. So 58 plus 208 gives you 266 grams. And then 176 plus 90 gives you 266 grams. So this reaction obeys the law of conservation of mass. Now, let's look at some problems. Suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide. How many grams of water will form? So a lot of these conservation of mass reactions are going to involve combustion reactions. And one of the foundations of combustion reactions, and I'll write this at the bottom, combustion reactions, something reacts with oxygen to produce CO2 and water, or you can see carbon monoxide and water. So with these types of reactions and law of conservation of mass, you will be given 3 of the 4 masses, so you can figure out the other mass. So let's go to this question again. Suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide. How many grams of water form? So if you have no idea how to start this, my advice is to just start with an arrow. And then after that, you can determine what's on the left, what's on the right, what's a reactant, what's a product. So 12 grams of natural gas, so we have natural gas here, combining with oxygen to produce carbon dioxide, which is CO2, and water. So 12 grams of natural gas, 48 grams of oxygen, 33 grams of carbon dioxide, and so the question is, how much water will form? So what you do is add 12 plus 48, you get 60, so that equals 60. So to get the mass of water, you're going to take 60 minus 33, and that will give you 27. So 27 grams of water is what you're looking for there. All right, so let's look at the next problem. A chemist forms 16.6 grams of potassium iodide by combining 3.9 grams of potassium with 12.7 grams of iodine. Show that these results are consistent with the law of conservation of mass. Okay, so this is a case where it's not a combustion reaction. Still, if you have no idea where to start, just put that arrow. What is this chemist making? Potassium iodide. So that would be Ki. And so he makes potassium iodide by combining potassium, so that's K, and iodine, which is I2. So 16.6 grams of potassium iodide, 3.9 grams of potassium, 12.7 grams of iodine. You're just asked to prove this. So 3.9 plus 12.7 gives you 16.6. So this does adhere or follow the law of conservation of mass. Okay, so next we're going to talk about the law of definite proportions. So Joseph Proust carried out several experiments to determine which elements and how much of each elements were in a compound. He discovered that compounds were composed of elements in simple ratios. For example, water always contains 8 grams of oxygen to 1 gram of hydrogen. He called this the law of definite proportions. Compounds are composed of elements in definite ratios, regardless of the source of the compound. So, compounds are composed of elements in definite ratios. Okay, so for example, water. All right, so let's look at an example of the law of definite proportions. So to make a sandwich, I need 2 slices of bread and 1 slice of ham. So need 2 slices of bread, 1 slice of ham. Now, if you're my husband, you need about 2 slices of bread and 6 slices of ham. Everybody's different. So, all right, let's say, suppose I have suppose I have 6 slices of bread. How many sandwiches can I make? So you need 2 slices of bread, so you could make 3 sandwiches. All right, what if I had 8 slices of bread? 8 slices of bread and 10 slices of ham. So you could make 4 sandwiches. Because we know that a sandwich is always made of 2 slices of bread and 1 slice of ham. So if you have 8 slices of bread, but only 3 slices of ham, how many sandwiches can you make? You can only make 3 sandwiches. And you'll have 2 pieces of bread left over. Okay. So now let's talk about a chemical reaction. So to make carbon dioxide, carbon dioxide. Carbon must react with oxygen in a very specific ratio. So you have 3 grams of carbon plus 8 grams of oxygen, and that gives you carbon dioxide. So this proves the conservation of mass, where we can show that if you have 3 grams of carbon and 8 grams of oxygen, you will end up with 11 grams of carbon dioxide. So let's say, suppose you have 9 grams of carbon. So my question to you then is, how much oxygen is needed? How much carbon dioxide is made? Okay, so we know that we need 3 grams. So 3 times 3 is 9. So if we factor in the same increase, 8 times 3 will give you 24 grams of oxygen, because this was 3 times 3, and this is 3 times 8. And then you're going to multiply the carbon dioxide by 3. So you'll get 3 times 11, or 33 grams. All right, let's say, suppose I have 12 grams of carbon and 40 grams of oxygen. So I want to know how much carbon dioxide I will make. Okay, well, let's see, 3 times 4 is 12, 8 times 4 is 32. So that means, so I have 3 times 4, which gives you 12. If I do 8 times 4, that gives me 32. So all I need is 32 grams of oxygen. So I have extra oxygen. So I do 3 times 4 gives me 12. So then I'm going to have 4 times 11 for carbon dioxide, which will give me 44 grams of carbon dioxide. And I'm going to have 8 grams of oxygen left over, because we have extra oxygen. So it's important to point that out. Now on the next page, I have some exercises that don't necessarily involve chemicals. It's kind of nice. So that last example was maybe getting a little too complicated. So I have given you some information to answer these questions. So in order to make one car, you need 4 tires, 1 steering wheel, 2 windshield wiper blades. In order to make silicon dioxide or glass, you need 7 grams of silicon, 8 grams of oxygen. In order to make acetone, you need 18 grams of carbon, 8 grams of oxygen, 3 grams of hydrogen. So there are questions, and I want you to try to use this information to answer these questions. Okay, so I'm going to walk you through these answers now. Question 1, how many cars can I make if I have 16 tires? Well, you need 4 tires per car, so 4 tires times 4 gives you 16. So 16 tires would make 4 cars. Now, the next question, how many cars can I make if I have 13 windshield wipers, unlimited tires, and unlimited steering wheels? We have to look at the windshield wipers since everything else is unlimited. And so 2 windshield wipers is 1 car. So 6 times 2 windshield wipers is 12 windshield wipers. So I could make 6 cars. And then I would have 1 left over. So 1 left over wiper. Okay, so how many cars can I make if I have 8 tires, 4 steering wheels, and 8 windshield wiper blades? What will be left over? So 1 car needs 4 tires, 1 steering wheel, 2 windshield wipers. So 2 cars need 8 tires, 2 steering wheels, 4 windshield wipers. I have enough for this. 3 cars needs 12 tires, 3 steering wheels, and 6 windshield wipers. I do not have enough tires. So I can make 2 cars. I will use up all the tires. I will have 2 steering wheels left over. 2 steering wheels left over, and I will have 4 windshield wipers left over. Okay, so the next question, how many grams of silicon dioxide can I make if I have 28 grams of silicon and unlimited oxygen? So 28 is 7 grams times 4, so that's a factor of 4. So if I take 15 grams and multiply it by 4, then I can get 60 grams of silicon dioxide. So the next question, how many grams of silicon dioxide can I make if I have 35 grams of silicon and 45 grams of oxygen? What will be left over? So 35 grams of silicon is 7 grams times 5. 45 grams of oxygen is 8 grams times 5. So that's 40 grams with 5 grams of leftover oxygen. So I take this 5 and I multiply it times the total, 15 grams of silicon dioxide, and I end up with 75 grams of silicon dioxide with 5 grams of oxygen left over. Okay, so on the next page, I have another question about silicon dioxide. How many grams of silicon dioxide can I make if I have 7 grams of silicon and 16 grams of oxygen? So 7 grams is the minimum, so I can only, necessary to make the silicon, so I can only make 15 grams of silicon dioxide, and 8 grams of oxygen would be left over because I need only 8 to react. 8 grams to react. Okay, so the next question, how many grams of acetone can I make if I have 36 grams of carbon, unlimited oxygen, and unlimited hydrogen? Well, 36 grams of carbon breaks down into 2 times 18 grams. So that means I can double the amount of acetone that was given in the criteria. So 29 grams times acetone, 29 grams of acetone times 2 gives you 58 grams of acetone. So the next question, how many grams of acetone can I make if I have 36 grams of carbon, 24 grams of oxygen, and unlimited H? So you just need to break this down. So 36 grams of carbon is 18 grams times 2. So that's lower. 24 grams of oxygen is 8 grams times 3. So I use the lower amount and figure out my total acetone that I can make. So that's 58 grams of acetone. So then I will have 8 grams oxygen left over because I had enough to make 3 times that amount, but I didn't have enough carbon. So the next question, how many grams of acetone can I make if I have 54 grams of carbon, unlimited oxygen, and 9 grams of hydrogen? Will any carbon or hydrogen be left over? So 54 grams of carbon is 18 grams times 3. You have unlimited oxygen. 9 grams of hydrogen is 3 grams times 3. So I can triple my amount of acetone made, so I'll get 87 grams of acetone. And lastly, how many grams of acetone can I make if I have 54 grams of carbon, 32 grams of oxygen, and 9 grams of hydrogen? What will be left over? So I go through and I figure out how the number of grams of carbon, oxygen, and hydrogen are increased. And it turns out 54 grams of carbon is 3 times 18, 32 grams of oxygen is 4 times 8, 9 grams of hydrogen is 3 times 3. So the largest I can make of acetone would be 3 times the amount, so 29 grams times 3. So I'd get 87 grams of acetone manufactured with only 8 grams of leftover oxygen. So there's it's definitely a process to which you have to go through to solve these problems. They can be a little confusing, but I think if you just think about it in terms of making a car, try to keep it simple. And definitely look at the total amount you're given and try to figure out what the necessary amount is increased by. Okay, so the last part of this lecture covers atomic theory. So Dalton proposed the atomic theory, which is the model used to explain the behavior of elements in chemical reactions. Okay, so all matter is made of very small particles called atoms. So atoms can now be seen with scanning electron microscopes, so we know they are real. A chemical reaction involves the rearrangement of atoms. Atoms cannot be destroyed, created, nor destroyed. So atoms can be destroyed in nuclear reactions, but not in chemical reactions. So we're just talking about chemical reactions, not nuclear reactions. So all atoms of a given element are the same. Atoms of different elements are different. So this has been kind of updated with isotopes. Updated. And what an isotope is you still have the same atomic number or the number of protons, but the number of neutrons differs. And compounds are formed when atoms of different elements combine in fixed proportions. So this is the law of definite proportions, which we just covered. And atoms of different elements have different masses. So this has been explained with the understanding of atomic structure and the number of protons and neutrons in an atom. So Dalton's theory explains prior observations about chemical reactions, such as the conservation of mass or the law of definite proportions, which we just talked about, and is still used today to understand chemistry. Conservation of mass is explained by assuming that atoms cannot be created or destroyed in chemical reactions. The law of definite proportions is explained by assuming that atoms combine to form compounds. It is not possible to have a fraction of an atom, so compounds always are composed of a simple ratio of elements. Okay, so Dalton originally believed that the formula of water was HO rather than H2O as we know today. Since he measured 8 grams of oxygen to 1 gram of hydrogen, he assumed that oxygen weighed 8 times as much as hydrogen. Following some experiments by Avogadro, it was deduced that the correct formula was H2O, which means that oxygen must weigh 16 times as much as hydrogen. The experimental ratio of 8 grams of oxygen to 1 grams of hydrogen is actually simplified from 16 grams of oxygen to 2 grams of hydrogen. So we will apply more of this atomic theory and the conservation of mass and coming up in the later sections of Unit 3. But for now, you understand the tenets of the atomic theory. These can be questions on the exam, but definitely more conceptual questions. So work your practice problems, especially with the conservation of mass and law of definite proportions, and I will see you next time for more Unit 3.